It's where we are considering the total weight of the body is acting. It is, you have to mention weight of the body. Center of gravity is an imaginary point where weight of the body is concentrated or weight of the object appears to act. You know, each and every particle in the in object has a weight. Each and every particle. They are using to calculate to determine the location of center of gravity. Which concept they are using? Moments concept. There is a mathematical part. We are not going to see that part, but they are using moments concept. Then they are finding out the center of gravity, the location of center of gravity. Okay, you have to uh, get a good idea. There is no a point there. It's an imaginary point. We are considering at that point the the whole weight is acting from that point only. But in actual practice, each and every particle in the object having weight, we are considering from the center of gravity, the total weight is acting. Okay. The center of gravity of a symmetrical body is along the axis of symmetry. It's a very important point. If the body or the object is symmetric, then center of gravity will act along the axis of symmetry. Actually, where? Along where? Exact point. Yes, exact point is the point of intersection of all lines of symmetry will be the center of gravity. Yes. For example, the left side you can see a rectangle or a cube. Those are symmetric objects. So you can see the lines of symmetricity. So at one point, all the lines are intersecting exactly in the middle, right? From that point, we are considering the weight of the object is acting. It is considered as, that point is considered as the center of gravity of a rectangle or a cube. You can get an example. Okay, the middle one, the center circle, you can see the center of gravity of a circle is in the middle, exactly in the center. You can draw the dotted line shows the lines of symmetricity. So all the lines are intersecting at the middle. So that's where the weight is acting. You can imagine a circular plate or a sphere, a solid sphere. The center of gravity of a solid sphere is at exactly in the middle. Okay. A rectangle. The center of gravity of rectangle is near the base. Here, all the symmetric lines are coinciding somewhere near to the base. At that point, the center of gravity is and the weight is acting there. Okay. And center of gravity is due to the gravitational field. You have to be aware of the gravitational field. Okay. At center of gravity, object can be balanced perfectly against gravity. If you find, if you can determine the center of gravity of any object, you can balance the object from that point. Okay. If we provide a support at center of gravity, the object will be in equilibrium condition. What's that mean? So center of gravity, if we balance an object exactly in the center of gravity, so the object will be in equilibrium condition. The forces are balanced when we balance the object, when we keep a support at the center of gravity, all the forces are balanced and the object is in equilibrium condition. Equilibrium means all the forces are balanced. The condition you can describe it. Okay. Center of gravity is denoted by CG or G. They will mention if they are using CG or G. It may lie inside or outside the object. Okay, what's that mean? The left side you can see, just imagine a solid sphere or a circular plate, a steel circular plate, yeah, a solid sphere. It is the center of gravity is inside the object. Okay, the right side, just imagine a ring or a hollow cylinder, a hollow sphere. The center of gravity lies outside the object. So it can be both inside or outside. Okay. Location of center of gravity depend upon the gravitational field, and this is the most important part. While you are differentiating this center of mass and center of gravity, so you can see the differences. Here, center of gravity, the location of center of gravity is depend upon gravitational field. If we change the gravitational field, the location of center of gravity will change. It may move down or up according to the location, according to the gravitational field strength. Okay, now you can see center of gravity is not a fixed position. It may change according to the gravitational field. Okay, now we'll see what is center of mass. Is it same as center of gravity, or those questions you can ask? Yes, it is not same as center of gravity. A completely different definition is there. In center of mass, the point in the body where all the masses of the body is assumed to be concentrated. Here we are talking about mass, but in center of gravity we are talking about weight of the object. Here, mass of the object. Mass is assumed to be concentrated. It is the center of distribution of mass of the object. So from center of mass, the mass of the object is uniformly distributed. Okay. Now, location of center of mass is independent of gravitational field. This is very important point. Difference between center of gravity and center of mass. Here, the location of center of mass is fixed. It is not, it is independent of gravitational field. Okay. If we change the gravitational field strength, center of mass is changing or not? It is not changing because it is independent of gravitational field. Okay. And the next point is it depend upon quantity of matter. If the mass, if there is more mass, the center of mass you can determine. If the mass is spread more, then you can determine the center of mass according to the spread of the mass. Okay. Only it will depend on the matter. Matter means the mass of the object. Okay. Now the question is the center of gravity, how does center of mass and center of gravity coincide each other? A good question, because for usual practice we are not making 2 points. We just show the center of gravity only. We're not showing center of mass or center of mass separately, center of gravity separately. Yes. The answer is when a body or an object is present in uniform gravitational field, then the center of mass and center of gravity coincide each other. It's a very important point. So If the body is under uniform gravitational field, center of mass and center of gravity will coincide each other. This is why usually near the Earth, the surface of Earth, we are not showing two different points for center of mass and center of gravity. So near, we are considering near Earth's surface, the gravitational field strength is uniform. Then the center of mass and center of gravity coincide each other. We are assuming that they are coinciding each other. Okay. Now we'll see the differences. What are the differences? When they ask the difference between the center of gravity and center of mass, first of all, in any question, it can be difference between scalar quantities and vector quantities. First of all, try to define both quantities. So both physical quantities, if you define itself, it shows most of the differences, right? Try to define it first. Exactly, what is the definition of center of gravity? Yes. Center of gravity is an imaginary point where the weight of the body is concentrated. Weight should be highlighted there. Weight of the body is concentrated or weight of body appears to act. It is an imaginary point. Okay. Center of mass, what is the definition? The point in the body where all the mass of the body is assumed to be concentrated. Okay, it is also imaginary point. Here we are talking about the mass of the object. It is the center of distribution of mass of the object. Okay, two different things. Center of mass talking about mass and center of gravity talking about weight. It is a force we are talking about. Okay, the next difference in center of gravity, a weight distribution of body around center of gravity is uniform. You can see from center of gravity, the weight distribution is uniform for each and every direction. You can see the weight distribution is uniform. Okay. In center of mass, the mass distribution around center of mass is uniform. At center of mass, you can see the mass, how the mass is distributed. It is uniformly distributed. Okay. This is why we can balance an object when if we know the center of gravity, we can balance the object because the weight is distributed throughout the body and around the center of gravity. Okay, the third one, center of gravity changes with the change in force of gravity. The gravitational field strength, if it is changing, the location of center of gravity will change according to the gravitational force. But center of mass, it remains unchanged with the change in gravitational field. It's like the center of mass is fixed. If the mass is constant and the shape is constant and center of mass is fixed, it is not changing if we change the gravitational field strength. But the center of gravity, it will change according to the force of gravity. Okay. One more difference I think you can remember, center of mass. Center of mass is depend upon the mass of the object, how it distributed. That's one more point you can identify. Okay. Uh, these differences are important, and those two concepts are the last two topics we have to discuss. Then center of gravity. How to find a center of gravity of non-uniform object. Just imagine a spoon. The top side of the spoon, there's more weight, right? More weight is concentrated there. So say, then here it's not exactly in the middle of the spoon, right? Okay. How to find? We are using another example is broom. The top side of the broom, the weight is more in top side of the broom. Okay. How to find uh, center of gravity in non-uniform objects? Okay. Here we are using the concept of moments. This is a actually practical session. I will explain in the physics lab a very simple practical session. We'll go through this practical session. I think it's a bit hard to explain in the online classes, so we'll do this practical session next week in the physics lab. Then you can do a calculation and find the exact location of center of gravity of non-uniform objects. How we gonna do it? We are going to balance the object first, and we are we are balancing the object and we are calculating the moments. Then we are finding the exact location. I will explain in the physics lab this experiment, a very simple one. And for moments topic, that's it. There are two more questions. Please do these two questions. And yesterday also I gave you some questions. Some students sent me the answers, and I corrected those things. And please try these questions. You can see the second question, a non-uniform bar. The weight is not acting at the exactly in the middle. Somewhere, somewhere in the bar, then it shows near to left side of the bar. Here they are asking to find the center of gravity, the location of center of gravity. Then you have to use which concept? Moment. Moment and forces. Try to use both concepts at this bar is in equilibrium. Use both concepts. Try to solve it. Question number one also try to solve it and send me the answers. If you have any doubts, we can discuss. I think in between classes it's very hard to discuss because very less time we have. Please do it yourself. We'll discuss. Uh, Send me the answers, then I can correct it for you. Okay. We'll start the next topic today. It is momentum. Before that, there are two worksheets to be discussed, forces and moments. Please complete all the questions. Try to complete all the questions. If you have any doubts in that also, you can ask me. Please complete in between this week so we can discuss in next week. If you try to do it, then you know I can do it or not. Then you can know you should do more to improve yourself. Okay. Momentum. Is it same as moment or different? Yes. Don't confuse. There are two completely different terms. Moment is the turning effect of a force. Moment is turning effect of a force. Momentum is completely different. It is related to mass of the object and mass of the object and the motion of the object. Yes, we'll see the momentum deeply here. Yes, momentum is a measurement of momentum is a measurement of mass in motion. Here, a mass in motion. Motion means we are measuring the velocity of the mass, a certain mass. How much mass in how much motion. So we need two variables here. So how much mass? The mass of the object. How much motion? How to find the motion? We are measuring in velocity. Okay. The amount of the amount of momentum that an object has is depend upon two variables. We can see two variables. What are the variables? How much stuff is moving. They are trying to explain how much mass is moving. Then I need mass to calculate momentum. Okay. The next one, how fast the mass is moving. How fast? Then I need the velocity. I need both mass and velocity. Okay. We'll see how to find the momentum, momentum of a object. Okay. Before that, some points we'll go through. Momentum depend upon the variables mass and velocity. Only mass and velocity momentum depend upon. Okay. Momentum is a vector quantity. When you describe momentum, when they ask to describe momentum, you can write the definition and also have to say it is a vector quantity. When you say, when you mention a physical quantity is a vector quantity, then it has both magnitude and direction. Okay. How to find the direction now? If it is a vector quantity, it is having a magnitude, yes, and also a direction. What is the direction of momentum of an object, a moving object? Yes. Mentioning the direction of momentum is very important because it's a vector quantity. And now they are saying about the direction. It is same as the direction of velocity. You know that mass is a scalar quantity, but velocity is a vector quantity which has both magnitude and direction. So the direction of momentum is same as the direction of velocity. If you know the direction of velocity, you should know because it's velocity. Velocity has both magnitude and direction. It is the direction of the momentum of the object. Okay, by definition, momentum is the product of mass of a particle and its velocity. Now they are saying how to find momentum. Momentum is the product of mass of a particle or object and its velocity. Okay, momentum is equal to mass into velocity. Okay, you can find the magnitude there and you have to mention the direction of momentum. Usually the symbol we are using is P. They may sometimes they may use any symbol, but you should know momentum and its definition exactly. Okay, momentum is equal to mass into velocity. Mass is measured in kilograms, velocity measured in meters per second, and momentum, the unit of momentum is kilogram meters per second. And please don't memorize those things, the units. If in any question, for example, multiple choice question, you just study the concept, the definition, write down the definition quickly, find out the units when you need it. No need to memorize those units. Okay. A simple example. A car is moving. Mass is 1000 kilograms and velocity is given 9 meters per second to east. Now they are giving the direction of the velocity. Okay, what is the momentum of the car? Okay, first of all, how to find the momentum? Momentum is mass into velocity. Okay, mass is given and velocity also given. Mass into velocity 1000 into 9. And one more important point, if the mass is given in any other units, grams, milligrams, or whatever the pounds, we have to convert into kilograms first, and velocity also. If they are giving centimeters per second, kilometers per hour, yes, you have to change it into meters per second, and then only you can find the momentum. Finally, momentum of the car is 9,000 kilograms meters per second to east. Here, the direction is given, and if they are mentioning just the direction is x positive direction, so you can show a arrow, or y positive, you can show arrow vertically upwards, y negative, vertically downwards. Like that, you can show a arrow also, the direction. Okay. While I am deriving Newton's second law, F equals to ma, you can remember I used the term momentum. I told you I will teach you later. Now you can, I think all of you can remember the law, second law, not only second law, all the three laws. According to Newton's second law of motion, the rate of change of momentum of object of a body is directly proportional to the resultant force applied to the body and is in the same direction. Okay. First of all, don't worry about the rate of change. Okay. First of all, what is the change in momentum? Change of momentum. Okay. Consider mass. This mass is moving, initial velocity is u, and the final velocity is v. Okay. Now, how to find the momentum? Initial momentum, mass into velocity, mu, and final velocity, m into v, mass into velocity. Uh, at both situation, the object is moving in the same direction. If the direction is changing, I will describe a question and how the sign, the positive and negative signs, how it changes. I will explain with a problem while we are solving it. Okay. Now, how to get the change in momentum? Final momentum minus initial momentum. mv minus mu, and the rate of change we can take change in momentum by time. mv minus mu by t. Okay, we can factor out m, then v minus u by t. It is the acceleration. The rate of change of velocity is the acceleration. This is how you derive Newton's second law. Newton's second law is not just F equals to ma. We have to know how to derive it. Okay, I think you understood the concept momentum. We will dive in to more in upcoming classes. I think time is up, right? Please send me those questions and the answers for the question. And regarding attendance, 36 students today, both class B and E, right? Class B, send me the attendance, and class E also send me the attendance separately. Uh, don't do not delay it. I have to report to school also. Thank you, students. We will meet tomorrow. Have a good day.